Hey everybody, Tom Cherryhomes here with the FujiNet project. And I wanted to do what may be a rather long video here showing exactly how I convert an existing BASIC game to be network playable under FujiNet. This particular game is a game of Roman checkers, also known as Othello, also known as Reversi. It's a two-player game, so it works rather well over TCP with two participants. To start, we'll actually set up a few little details so that we can actually get our work area set up properly. I'm going to use my local file server here and my local SD card slot. Start. I'm going to grab a copy of DOS. Actually, yeah, copy DOS. I want to grab a copy of DOS XL. I'm going to put it in drive 1 here. And I'm going to go ahead and make a work disk. For that, we're going to go to my file server here, use the new command to create a work disk that we can work on. And it's going to be a 90K disk. I don't need anything bigger. Are you sure? Yes, absolutely. And we're going to put it in drive 2. We are also going to take and bring a copy of the N handler across. Actually, I'm going to use my local copy here, but that's where you can get yours. I'll take and update the copy here by the time I post the video. We'll put this in drive 3 because we're going to use the auto-run sys on this disk and copy over once we've formatted everything and get it ready. So now with everything in place, we go ahead and boot the result. I just tap the option key because doesn't really matter if BASIC's there or not. You can see this is my special FujiNet startup disk that's available on the SD card zip that you can get on the Atari Age forums, and it contains all of the needed utilities for bouncing around with FujiNet. Now, the reason that we're using DOS XL here is because this is an in-progress version of the N handler. It is non-relocatable, which ultimately means that it's designed for one specific known memory map. The final version of the N handler will be relocatable. I'm waiting until all of the functionality is in and fully debugged before I make it relocatable, because it takes time and effort. There will be an upcoming video showing how I relocated the N handler as well, but I digress. To start, we have our blank disk sitting in drive 2, and you can see it has 0 free sectors, so we need to format it. I'll use the init tool to do so. We'll format the disk, write DOS sys, write to drive 2, yes. And then we exit. We now have a disk with DOS ready to go. And now I need to copy. If you look, you'll see the N handler disk in drive 3, which contains the auto-run sys, a few example programs, and some .com files. Well, the only thing we really need from here, absolutely, is the auto-run sys. So I'm going to go to drive 1, because copy.com is on drive 1. And copy auto-run sys to D2. We also need a copy of do.com from drive 1. And the reason we're going to use do.com will become evident later on in the video after we've finished our work. We're actually going to use it to take and automatically load the game. So now we kind of have all the bits and pieces that we need in order to have our game work. So with that, we can actually go ahead and tap the reset button on the FujiNet, because I actually want to do a slight reconfiguration now that our disk is ready. And cold start the machine. If we look, we'll see that our disks are here. We just need to take and do a little moving around. There is no swap feature yet, so I just need to eject what I have. Now that I'm essentially done with them. And insert my work disk, which is on my file server here. Insert, remembering to select read white. Tap the option key, and with that, we're off to the races. And with that, we are now inside our DOS XL environment with our in handler ready to go. Now, as part of this process here, I actually happen to have a copy of the Roman Checkers cassette that's been put into the cassette slot. I'm going to go ahead and load it into place. Engage the cassette. And we'll wait for this to load up. And yes, this happens at real time. There's no SIO patching. I'm not running this in an emulator. Just waiting for this to happen. With all the existential dread that comes with loading a cassette. And now we need to load the rest of it. I'm going to go ahead and pause here for just a moment. So 2.5 minutes later, we have our game loaded and ready to go. One thing to note is that this program was actually part of a list of cassettes that were commissioned by Sears to a company called the Image Producers Incorporated to produce initial software for the initial run of software that was going to be shipped with the Atari 400 and 800s available in the software catalog for Atari 400 and 800s sold through Sears. So that makes this some of the very first bits of software that was actually available for the system outside of Atari's own titles. And as part of this, it's very clear that Sears actually had talked with Atari to get information on how to program some of the video aspects of the machine. As you can see right here on this custom title screen here, we have some display list manipulation. The program is now loaded, and we can basically go ahead and I'll clear the graphics screen and we can have a little look at this. We'll basically see that there's really not much going on here. This is a very small program. It fits in about 3.5 to 4K and really works on machines even with only 8K of memory, which really was a requirement. It's very compact and it implements the game quite well at the expense of really not being that fast when you played the computer modes. But that's okay. We're not going to use them, and we wanted something simple enough to take and explain just how to take and move an existing basic game over to be a FujiNet network game. To start, let's go ahead and play around with this thing so you can kind of see. We'll just play a couple of hands. We run it, and it says type name and press return. Okay. 2 players. We find ourselves with a Roman checkers board. So you can, with this game, you can either use the keyboard or you can use a joystick. Both work just fine. And as part of the process, we're going to make sure that both of these things work as expected. To play Roman checkers, the objective is to find a color, find an opposing square. Since I'm the dark blue here, I need to find a cream-colored square to be next to because I'm going to flank these three pieces. Boom. And now Bob's turn. Bob can take and do the same thing for me. Boom. And so on and so on. All in all, it's a really good implementation of the Othello game. I'm actually very impressed that they were able to squeeze this in as well as they did, and as small as they did. So you can see that this works. It's a turn-based game, which will translate very well to into making it a FujiNet network game. But let's start making some changes. Go ahead and hit the break key here. And we're going to notice, first and foremost, these colors absolutely suck. So let's just change them, please, for the love of God. First, let's set the background to something a bit more pleasing. Something a nice dark green here, like nice light green. Then let's go ahead and set the, I apologize here, I'm looking at my notes as quickly as I can. I can never look at this stuff fast enough. How are you? Oh, there you are. Did I? 413? Watch. Boom. So now, all of a sudden, immediately a big improvement just by changing those two colors. But I want to take and use more appropriate colors for the individual pieces, white and black, like it is in the real board game. So for that, all we do is set the next one here. Boom. And we can leave that one cream colored. That kind of works. Or we can go ahead and set the opposing color white. And with that, you know, bam, we have our updated color palette. So let's go ahead and change that. First and foremost, those are set in line 710, 720. So let's go to graphics 0 and set those colors appropriately. Let's in. And we're just changing the existing values quick enough, at least. Followed by. And if we go to 700 now, we'll see our new color changes. Ready to go. Bam. Awesome. There's our first change. Let's go ahead and save Othello here to the disk. Or just call it Reversi. Othello is a trademark. Call it Reversi. So, moving forward, now we actually start to think about the bits and pieces that we need to implement network play. Well, we look at line 500, we will actually see that we have our existing variables and arrays that we have here. A for player 1, B for player 2. These are not actually going to be used in our implementation and are flags for the computer. And finally, we keep an array of 9 previous scores for the scoreboard. I won't be doing much with this, but maybe as an exercise, you guys can take and make something out of this. We're going to go ahead and add 2 variables here, one to hold the host name, and one to hold the device spec for that host name, both 64 characters, which should be sufficient to hold a large enough host name. We also need to add an additional variable to flag whether or not we're listening for a connection or not. Furthermore, if we take a look now, we can see that there's not much going on here, but you see just before 600, we have some space in which we can take and add some additional bits and pieces that we need to set up the network from the user side of things. So we'll go ahead and add that in. First, we go ahead and do a little spacey, sorry. 520, 530, 531. A little note. Follow that up by 540. Oop. Let me turn my caps lock back on. Now we're going to use a little trick here to get rid of the question mark here, and we're going to use input number 16, and we're going to grab the host name with that. This will remove the question mark from the prompt and just take cursor input directly. Follow this up entirely by, if the host name is empty, then we assume that we're listening. Followed up by, oops, yeah. Followed up by the command here, the variable setting that sets up our device spec. Since we're using TCP, we're going to use the TCP device spec here, starting off with the necessary preamble. Then we're going to add on to it using the method that you use in Atari Basic to add on to such strings. Add the host name, followed by, again, adding on to the end again, ending the string. So with this, once this is done, we will have our host name in H, which will then immediately be used to construct our device spec in D with TCP and the required port number of 6502. And since the only difference between a server port that listens and a client port that connects is the host name, we can use the same variable setting for both. Follow that up now. If this is where things get kind of interesting. So now we actually need to start to open a network connection now that we have it. And for the sake of development right now, we're going to set aux2 to 2 so that it's compatible with my test system over here. When we get ready to save and deploy the program, we're going to change this back to 0. That's all we need to do right there to open our network connection for both listening and connecting. Same thing either way. If we aren't listening, then we go ahead and immediately go to 600 because it's assumed if we're not listening, then we've already connected and we're ready to go, and we can immediately start asking for a name. However, if we are listening, then we need to get the status of the connection, and if we get a connection, which we check to see if 748 is equal to 1, if it's equal to 0, then we immediately go back to 580 again and just wait there. All we're doing here, this is all you need to do to wait for a connection. Otherwise, we can say this, but this will happen so quick you won't see it. You might want to maybe, finally, accepting connection. And then we go ahead and accept the connection. We accept the connection using XIO 65. And 65 is the ASCII number for the capital A for accept. To 12. And this is what I get for actually setting this up. Now, I need to make a slight change here. My bad, because number 1 is already used for the keyboard, I actually need to use number 2. Apologies, this demo is going to be rife full of this. I hope you guys get the right point regardless. So we accept the connection, and once this is done, you are now connected to the other side. The other side is now connected to you, and the other machine can start sending packets, and you can send packets back. Great. For the sake of being able to show that this is happening, we're just going to put a simple delay in here. With that, okay, great. We don't have to do that, but we're doing that just so we can see this message. And finally, 582 go to 600. You don't really need to do that, but you can. So now we're at 600, and 600, of course, you can see that we are accepting name inputs. Now for this, we actually need to do a bit of finagling here. We only want to accept our player names for the player that's actually going to, that's actually going to be accepting here. And the general logic for this is if I'm listening for a connection, then I'm player 1. If I'm connecting to someone else, then I'm player 2. So with that, it becomes pretty clear how we want to take and implement this. So we start by saying, if not listening, then we go to 620. 620, of course, is player 2. Otherwise, 611 becomes new line, print. We do our first little bit of I/O now. The first thing that we do is we send our player name, and we immediately ask for the other player. We follow that up by going to 700, which is the beginning of the board drawing stage. Okay, so with that, we do the same thing for the other side. So now we've essentially done our first little bit of network input and output here. We output our name here that we get from the previous input statement, and we immediately ask for the opposing player's name, in both cases mirrored, depending on whether or not we're listening or not. That's essentially all we really have to do. But we also have to make sure that we bounce past all of this so we don't accidentally trip over any logic we don't want to set. We could just as easily basically just bounce over to this if we wanted to, but since we're not really supporting any computer players, it's okay to just jump over this. So finally we get to the 700s, and the 700s are literally where we start to draw the board. Not really anything here that we need to modify here other than the board colors that we changed. Those are already changed. So we're pretty good there. We'll go ahead and look through 880, 800 through 900. And again, nothing really special here. The only thing that happens here is essentially this sets up the initial pieces for the board, and the positions of each piece is actually read from these data statements. So that puts the initial 4 pieces on the board. Moving forward, we actually start to get into a little dash of initialization logic to set the player number correctly, followed by what is essentially the start of our main loops of the game, which starts 1000, 1500, etc. So we actually get into what is essentially the main loop of the game. So looking here at my notes, I need to see what I actually need to modify here. Give me just a moment. The first thing that we actually need to modify is we want to actually emit whenever a player changes their cursor position so that the other player can see that they're trying to make a move. Visual feedback is important. And for that, we're looking on lines 1500 to 1600. And you'll see the majority, this is where the joystick and key logic is actually handled. And it's where it's basically where we need to start making the first bits of our changes. To start with, we absolutely are not going to use any other joysticks other than 0, and we're going to use the keyboard as is. So we need to change these. P is the current player number, which gets subtracted so that the 1 based value becomes a 0 based value. And we just need to change this to 0. We need to do the same thing for this. This is so that no matter which player is actually selected, it'll still use the first joystick here. Since we're playing remotely, this is the behavior that we would expect. Boom. The next thing that we need to do, we need to actually go ahead and modify 1530 ever so slightly here. You can see this is the big here is this is if a trigger gets set, or if the space bar gets hit, or if the return key gets hit, then go ahead and try to execute the move. We need to go ahead and actually bump this down by 1 line because we need to add some additional logic here. So we'll go ahead and change this to 1699. Because I need to take and put a little bit of extra logic just before. We need to see, okay, and let's see, apologies here. We need to add some additional logic here. The 1511 and 1512. And this basically deals with making sure that the other player is disabled if the other one player is disabled while the other one is going. And what this essentially does is bypass all of the joystick logic if it's not your turn. (1511, 1512). So that basically makes sure that if it's not your turn, then you basically get boom, done. So let's see what else. Okay, let's go ahead and clear the screen real quick and relist. So we can see there's our new lines. And if you look, we come all the way down to the end of 1500, which is our joystick processing line. And we finally do our player output sound here. But we need to do one more thing here. We want to be able to transmit our new position if it changes. This loop only goes through if, by some way, something up here changes. So it calculates the new X values, which happen to be screen pixel positions, into X, into Y. These are our X and Y coordinates that we absolutely need. We also want to be able to track the trigger position as well, so that we know whether or not this is just the player moving, or if this is the player selecting a move. To do this, all we need to do is add an additional line down here to transmit the move to the other side. For that, 1581, and 1581 is literally this. That's it. That's all we have to do to transmit a change in movement. That's the first part of what we need to do here. Let me make sure that there's nothing else here. And remember that we have, if we actually take and bounce across, we'll look now at 1600 to 1700. And this is essentially this is the move calculation here. We check the move, go to 5000 to verify if the move is valid. If it is, then we take and go through the game loop again. Otherwise, we say it's an invalid move and we ask them to do it again. Boom. 1700 here. So 1700 is called whenever we need to execute and do a move. But we need to do one more thing before we actually get here. This is why I changed the 1700 to a 1699. What we need to do here again is to do another print of the same thing. And we could actually use a subroutine for this. Pretty much the same thing here, but we need to make sure that when we select a move, it gets sent, that when we move the cursor, it gets sent. So those are the two places that we need to absolutely make sure that our moves get updated. Okay. Now, let's see, anything else that we need to do? I think that actually might be the extent of the sending that we need to do. We make double sure. And yes, it is. Okay. So with that, that's our sending. But what about receiving? The receiving bits are actually need to be taken care of in the parts of the program that run the most, and those are the topmost parts of the program. If we look at lines 0 to 100, we'll see a whole set of subroutines. These get called all throughout the program whenever a piece needs to be updated, whenever something needs to be drawn, etc. And in our case, all we need to do is place something down here at the very bottom of this subroutine, which is called every single time a piece needs to be updated and the sound needs to be updated as well. The reason that these are up here at the first of the program has to do with how Atari Basic parses its line numbers. Specifically, lower line numbers execute faster than higher line numbers. Mostly because Atari Basic literally sorts through every single line in a program whenever a branch is executed until the line is found. So for this, all we need to do is check to see if something is available on the network. And if it is, we check the number of bytes waiting. And if we do have anything waiting, then we go ahead and do that. Because we did the format on line 1699, on lines 1581, with the commas in them, we can immediately input that data with a single input statement here, X, Y, and trig, and get all the values that we need in one shot. If trig is actually triggered, then we go ahead and execute the move. Let's just go ahead and get it out of the way. Done. Boom. And that's really it, fellas. That's all we needed to do to really make this game work with FujiNet. Now let's test it. For that, I'm actually going to take and open up a little window here. That's my terminal window. And get him ready. And we're going to run the game. We're going to save the game first. Actually, I'm going to do one little change here to get rid of some horrible buzzing, at least until I can get the relocator done and everything finished on the handler. Save that out. Oh, we want to do one more thing as well. We want to trap 3000 in case anything goes wrong with the network. And 3000 is a single statement. Graphics 0, disconnected, and we close number 2, and just goodbye, close everything off. We're good to go. Bam. And just for the sake of it, we will do 65.3. And if we actually have in here, since this program doesn't end any other way here, that's fine. So save. Boom. Boom. Be sure to forward port 6502, host name, or return to listen. We're going to listen for a connection. Oop, something went wrong there. What went wrong? Let's see. We'll go ahead and get rid of that for just temporarily. Error 144, which probably means I need to reset. So we'll go ahead and just, if this happens for whatever reason, we'll have a little look here. Okay. I'm going to go ahead and tap the reset button, and we're going to come back into this. Give it a few moments. And now we're waiting for a connection. For this next piece, I'm actually going to go over here to my PC, which I'm using as my test harness. Since my daughter's XEGS is up in the upstairs area, and she's currently at school, I can't really use it. So I need to have a testing harness here. No big deal. We'll go ahead and use the netcat tool to connect to my FujiNet, which is named Tom, port 6502. And we accept the connection. Boom, there we go. And at that point, put in my name, which is immediately sent, and it's waiting for my name over here. It's waiting for exactly the same thing to happen over here. I'll go ahead and enter my name here. Boom. That. We go into the game. And you'll see that as I move, I'm going to pair my joystick here. Give it just a few moments to stop blinking. And as I move, we see our telemetry show up. So I'm going to make note that's 4721. And since that's a comma 1, this means that the trigger isn't set, so it's just doing a cursor. Bam, boom, 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 bop, bop, bop. 4717, now triggered. We seem to be in computer mode. That's interesting. Yes, the computer it's now in computer mode. Oh, what happened there? Let's see if it actually decides it's going to... Yeah, it's in computer mode. Whoopsie. Okay, well, let's see what happened here. Good thing is that we have a socket ready to go, and we can hit the break key. And I'm basically going to make sure, for whatever reason, I'm going to look and see what F0 is 0. Whoa! Hello! That would be Y. Wow! What happened there? Okay. Well, I guess I guess we'll take and set that, because that's not supposed to be set. And if we actually take a look in the code, we see that that actually is set. Lines 6, 25, 28, so fine. We'll just basically do this. Go to 700, okay, fine. So those values aren't being set. So I think the solution here is to go ahead and move that up a little bit. We will put that in 581, 5. Do I have a 573? I don't. I'll go ahead and move that up and just keep that there. But for right now, we're gonna bypass it. But that should solve that problem. Careful with uninitialized arrays. Good debugging tip. Okay. We'll go ahead and save the changes anyway, since it's a good change. And we will go to 700. And come back to the game here. Bam. Restart. And again, as we start moving across, we will see our telemetry change. Trigger, sending the telemetry. And now Bob is no longer under the control of the computer, so Bob can be effectively moved. I'm going to go ahead and go to my network terminal window here and set the appropriate values. So if I go ahead and set that, for example, boom, you'll see him move. There is a slight bug here where the cursor doesn't go away. This is just something that would be a good exercise to make sure that the cursor goes away if it's being displayed when we take it in, when we get some internal data here. But if I go to where I want to go, boom, 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 boom. There it is. And then we'll go ahead and select it. Boom. And there we go. And so on and so on. It's harmless because it doesn't, because once the cursor actually gets updated, okay, we're good anyway. But you can see the game is working exactly as expected. Invalid moves and all. So there we go. This is pretty much everything you need to do in order to take a game that already exists and convert it into FujiNet. And notice that all we used were the open, clothes, status, input, and print statements to do all the network traffic that we needed to do. The only XIO that we needed was to accept an incoming server connection. But here you have a game that does not require an explicit server to connect to, but can be played peer-to-peer. You just have to remember to forward port 6502 TCP to your FujiNet. So with that, we're going to go ahead and end this particular tutorial here. I hope you guys found this interesting and informative, and if you have any questions, of course, you can always ask me on Atari Age, on Facebook, on Twitter. Feel free to ask me any questions that you may have. Hopefully this will give some guides here as to porting other games such as Oil Well or any other turn-based games, or to give enough of a template to show how to make your own turn-based games in BASIC. So until next time, guys, have fun.